Okay, everyone, it looks like we have all the attendees we're going to get for today, so I'm going to go ahead and get started. Thank you for joining us for another one of our LabChart Mastery series. Today we're going to discuss cardiovascular analysis, excuse me, both using our ECG Analysis module, our HRV module, and the Cardiac Axis extension. Unfortunately, Brandon Boucher could not be with us today, so I'm taking over for him. My name is David Ream. I'm the Technical Support Engineer for AD Instruments North America, and I am based out of our Colorado Springs, Colorado office. Before we get into the meat of the webinar, I want to talk about some of the webinar guidelines. As you've probably already noticed, the audio for all attendees is muted during the presentation. This is just to keep background noise to a minimum during the presentation and interruptions to a minimum to make sure we get through all of our material that we would like to cover today. The primary ways to interact with me are through the GoToWebinar toolbar. So if you have a question during the webinar, please go ahead and enter it either into the chat option or the questions option in this toolbar, and I'll answer them in the order they were received at the end of the webinar. And if you are using a Macintosh, this is what your interface will look like on the left here. If you're using a Windows machine, this is what it will look like on the right. Very similar, all basically the same options in the same places. Also, I'd like to talk about our upcoming training calendar. All of these right here are in-person courses that are being held either at our Boston, Massachusetts office or Colorado Springs, Colorado office. So from the 21st to the 22nd of August 2013, we are holding a LabChart training course levels 1 through 3 in Boston. On the 11th to the 12th of September 2013, we're going to be holding the same course here at our Colorado Springs, Colorado location. And then again, we're going to be holding the same course in Boston on the 17th and 18th of September. So a lot of options out there for you, whether you're East Coast or West Coast. And also, we're excited to mention that we're co-hosting a mouse and rat microsurgical techniques workshop with Wake Forest University in Winston-Salem, North Carolina on the 18th and 20th of September. This will be the first session. The following week, there will be the exact same course, but there will be a second session. Also, I'm going to go ahead and send something out via chat here. For those webinar attendees out there, we have this special promo going right now. If you bring 2 people to a LabChart training course, you get 10% off. And you can get the code for this depending on the location you're going to go to from the chat message I just sent out to everybody. You just click on that link there and it'll give you the 10% off code. If you bring more than 2 people, definitely talk to us. We would be very open to maybe increasing that discount by a couple more percent. So definitely, if you, after going through the webinar, you still have other questions and would like to attend one of our in-person training courses here, definitely click on these links, get that code, and realize those savings that we're offering you guys. Next, I'm going to talk about some upcoming LabChart Mastery webinars. The next one's going to be quantifying pharmacological effects using the dose response module, and that will be on the 20th of August. We do have other ones scheduled further out, but we just haven't put them up on the website yet, so definitely check in at www.adinstruments.com/events and keep an eye on that and look for any upcoming webinars that are available. Also, if you want to just know what's going on with AD Instruments, you can follow us on your social network of choice. We're out there on YouTube. There's some great training videos on YouTube and how-tos. We're on Facebook. You can learn a lot about what AD Instruments' equipment and software is being used for on the research front. LinkedIn, we're available there. We do have a Twitter account and also on Google+. So by all means, check in on us. We'd love to show you what we're involved in with our equipment and our software. And before we get into it, we're going to talk about kind of some just general boilerplate here that we like to put out because it's a common question for us. You don't have to read all of this statement of intended use. The take-home message here is that no product supplied by AD Instruments is intended to be used to diagnose, treat, or monitor a subject, where it's not intended to be used in the clinical environment to actually treat somebody or diagnose somebody. You can use it for clinical research, but you cannot use it as a patient monitor. We also get a common question of, well, how do I know what I can connect my AD Instruments equipment to? Is it safe for human connection? Any of our equipment that is safe for human connection is going to have this body protected symbol on it. Anything that's safe for a direct cardiac connection is going to have the cardiac protection symbol that you see here. So definitely look at those things before we start connecting them to a human subject, just to make sure that we're not endangering anybody and that it's properly isolated. Also get a question quite often, how do I know what's coming out of the Power Lab is what really is being input into it? How do I know what I see in LabChart is true? We spent a considerable time and money to get quality ISO 9001 certified as a quality management system. Just that they look at our manufacturing process, our validation processes, our design processes to make sure that we're meeting current standards for the production of biomedical research equipment, and that we are what we say is coming out and what is being input into the Power Lab and going through LabChart is actually what is happening. So the certificate for this certification is on our website, so if you have any sort of ERB processes, you can definitely go out to our website and download that, because it may come up in the review. So thankfully, that gets us through our opening little spiel here, and we'll get into the meat of what we're going to talk about today. Today's webinar program is going to kind of roughly follow this outline here. First, we're going to talk about the ECG Analysis module, the module setup, the different analysis features. Then we're going to move on to HRV. That will probably take up a good portion of the webinar. Talk about its module setup, the analysis features. There's a lot there. And then last but not least, the Cardiac Axis extension, which is free to any LabChart user. You do not have to have LabChart Pro or purchase it. And just talk about its extension setup and how the analysis features it offers. So that takes me through my presentation for today, and let's go ahead and move into LabChart. So I have a ECG here recorded from a rabbit, just something that we can analyze with the ECG Analysis module. A word about the ECG Analysis module: it allows you to analyze both offline and online. So while you are collecting data, you can actually analyze that data as it's coming in and see real-time analysis being performed. And actually this file here, you'll see some T-wave prolongation. Later on when I show you some of the analysis views, it's actually the drug that's being applied to this rabbit will cause T-wave prolongation. So first things first. All of our modules, when they're installed, will give you a drop-down menu up here that allow you to access settings, the different views, tell LabChart how to analyze and when to analyze. But they'll also give you toolbar tips here, little shortcuts to specific features of the module. So for instance, with the ECG Analysis module, it shows up our toolbar tip here. We can have a shortcut to settings, a shortcut to the ECG beat classifier view, the ECG averaging view, the ECG table view, the analysis plots, and we can also tell it to analyze here. So just nice little shortcuts, so you don't always have to keep going back up, clicking the drop-down menu, and scrolling through here. We have these nice icons that allow you to get the specific features within the module. Going back to our ECG Analysis drop-down menu, the first thing I'm going to talk about is settings. How do we set up the module to actually analyze our ECG data? So once again, ECG Analysis, Settings. I left-click this, and up comes the ECG Analysis module settings. First thing you'll notice in the upper left-hand corner here is we have to choose a data source. What channel in LabChart is this ECG signal being recorded on? Pretty easy with our file here. We only have one channel, so we will select ECG. Do I want to analyze this whole channel, or do I actually want to go ahead and analyze a specific selection? For this file, it's very short. Analyzing the whole channel will be relatively easy. It won't really bog down the computer. If you have many hours of ECG data that you're trying to analyze, it might be helpful to only analyze a specific selection. And I'll kind of show you how to do that later on here, just to keep the system load on the computer down. Over to the right-hand side, we start talking about how are we detecting QRS complexes, how do we find each individual ECG event, each beat. LabChart uses a variety of detection algorithms, but some of the parameters that it uses is to look for a typical QRS width. Now, by no means are these set in stone. You can definitely go through and change them, whatever works best for your data, because depending on what you're doing to your test subject, these may vary. Typical for a rabbit file like this, we're going to look for QRS widths of 35 milliseconds. And it's going to also ask, okay, when should I start looking for another R wave again? R waves are at least 200 milliseconds apart. And the way the ECG Analysis module works is it looks for the R waves first, finds them, and then looks to either side and specific windows for the individual ECG components. We can also tell the module where we want alignment to be. QRS maximum, it's going to usually end up on the R wave. However, for some ECG structures, the QRS structures, it might be easier to go to the QRS minimum. I'm going to leave it on maximum for this particular file. Now, as I mentioned, LabChart first goes through, finds the R waves, and centers on those if we're doing QRS max. And it's a normal ECG structure, QRS structure. Then, from the R wave, it looks for a specific window to the left for the PR interval, and looks for the PR wave, detects it within that interval, looks even farther past that for a specific window for the baseline before we get into any of the ECG complex. Same with going over to the T wave. Maximum RT looks for a certain window in order to identify the T wave. For a rabbit, we wouldn't have this checked, but for mice and rats, rodent T-wave structure is different than larger mammals, so we're going to want to go ahead and click that, and you'll see it'll actually move the T-wave over. Usually the rodent T-wave is like right on top of the QRS complex. There's no delay between like we would have with larger mammals. Also, for measuring the ST segment height, it allows us to fine-tune that here as well. How far away from the R wave do I want to measure that? You'll also notice here, after we've gone through kind of the more intensive detection settings, we have some detection analysis settings that are preset. Very common animal models that you would be using. Large dog, small dog, guinea pig, human, mouse, pig, rabbit, rat, common lab animals that we perform ECG experiments upon. Of course, we have rabbit here, but these are just simple presets that will change all these values. So for instance, I'm going to switch to human here. And you'll see these things change. And we can go back to rabbit. And you'll also notice when we go down to, say, a mouse, rodent T-wave is checked. But by no means when I do this preset, do I have to stick with these. I can change them according to how my ECG signals look. So I'm going to go ahead and move back to rabbit. We can talk about averaging. The ECG analysis can average over multiple beats. Just for us to get any variation out, that might be noise in the background or just something that's not physiological, we can get an average over 4 beats and get an average waveform from those and actually analyze that. You don't have to average if you don't want to. If you don't want to, just go down to 1 beat. But I'll put it back to 4. We can average over a specific time or with blocks of recorded data. So we start and stop recording. We can average across a specific block. So for the QTC, this is a correction of the QT interval for heart rate. I'm not going to go into this too far, just different ways of correcting it, different methods. There's no right or wrong here. Just choose whatever your guide that you're using for your experiment recommends. And last but not least, the help menu dialog. You'll see this in a lot of our module settings windows or other settings windows in LabChart, we have these little hot buttons that go straight to the help dialog for the ECG module. So very helpful. If you forget what something means in here, we can go in and look, and it'll give you a nice description of what everything is. Okay, well, what does QTC interval correction mean? Talk about it. Talk about the different methods, how they're being multiplied times the QT interval to actually correct it. So definitely do not be afraid of our help menu. It's basically a paperless software manual, and it'll get you out of trouble 9 times out of 10. So I'm going to go ahead and analyze the whole channel. I'm going to hit OK. You'll notice when I analyze that I get these little green markers. This means that the ECG Analysis module has analyzed these beats. It's detected a beat here. If we left click on them, we can look at them and say, okay, it's beat 12 in our analysis. The RR interval is 0.31 seconds, and it occurs at time 3.9 seconds. And it's done it for the whole file. Now you will notice whenever our modules analyze a section, we'll probably miss a beat, we'll have a grayed out dot and then a green one. The grayed out, LabChart is not using this. The reason that is because it needs a couple of beats to be able to perform the calculations accurately. So usually it's either the first or the second beat in the beginning, and usually the last beat either gets detected but doesn't get brought into the analysis or just doesn't get detected at all. And I mentioned that I would talk about what it looks like, or how do we do analysis on a selection. So I'm going to go back to ECG Analysis settings. I'm going to click the selection radio button. I hit OK. I left click and hold and drag. In LabChart I can do this. I could go down to the time axis down here, left click and hold, drag, select a region in the data. I can go to our toolbar icon here that says Analyze, or I can go to Analysis, Analyze Selection, and LabChart only analyzes that selection. Like I said, you don't have to do it this way. You can do a whole file if you want to, but it can be helpful if you have really large files, just to keep your computer from getting bogged down from grinding through and doing all the calculations necessary. If we want to clear that analysis, we can. And I'm going to mention briefly that ECG Analysis module is one of the things that is actually enabled in the Analysis Manager view in LabChart. I'm not going to talk about that. It's a little bit off topic for us, and it will be covered in another webinar. Or if you're even more curious about it, we talk about it extensively during one of our workshops and how it integrates with different modules. You'll also notice that if I will kind of talk about the things that are available here in the drop-down menu, I'm going to go back to whole channel analysis. Hit OK. We've already talked about settings. We'll talk about beat classifier view in a little bit, averaging view, table view, and the different analysis plots that are available, and also table view options. I can tell the module to show the beat markers, these green dots, or I can say don't. If you find them distracting, I usually like to have them up there. We can classify all beats as good, or we can actually, using the beat classifier view, which we'll talk about in a little bit, talk about how you can not classify them all as good. You can analyze while sampling. If you want to analyze and have channel outputs that are being performed during sampling, you would check this and it will update in real time. You can reselect the analyzed data. Just click that and it'll select your analysis region. I can clear the analysis here, or as you saw before, I can analyze the channel or analyze my specific selection that I have made. So just kind of a quick run through on those. Next, we're going to talk about the beat classifier view. And this is where I can actually see how LabChart is actually classifying beats as good. Now you'll notice that there's these red boxes around all the beats. Each one of these X's is a beat. And I'm going to do a smart tile here so we can see. Let's do a different tile actually. So we can see the chart view and also see the beat classifier view. Now if I click on these, you'll see that it is linked to the chart view and takes me to that specific beat. No matter which one I click in. Now the parameters for how these are put out here, activity and isoelectric noise. Activity is a measure of sample-to-sample voltage differences summed over the entire beat. And higher values indicate more noise contamination. So the noisier the recording for a specific beat, the higher it is going to have for activity. Isoelectric noise, which is the x-axis here on the left graph, is a measure of the imprecision of the isoelectric value. And high values mean contamination by noise, or the previous beat's T wave is running into the next beat. Now over here on the right-hand side, we have form factor and RR interval. RR interval, pretty self-explanatory, the interval between each R wave. Then we have form factor. Form factor is how well the signal conforms to the given ECG template, indicator of how complex the signal is. It's not necessarily bad, but could be an indication of disease state. Okay, we're recording from this rabbit, but it is not showing. It's not conforming to a known good rabbit ECG form for lead 1. It's looking a little off from it. Now, according to these factors, we can tell LabChart not to. If I go ahead, left mouse click and hold, and drag these red boxes down, I can tell it, okay, those are bad beats. This is a good beat. This is a bad beat. Do not use it in the analysis. The dots out here will turn red. When they're outside the box in this graph, the activity isoelectric. They will turn blue when they're outside, just outside of the form factor and RR interval. However, if they're outside of both, they'll actually turn purple. Let me see if I can get a purple one here. If they're outside of both these boxes, they'll turn purple. Just to give you an idea of how things, the color code means, and if we're excluding beats, what it means, where are they failing to fit into our definition of a good ECG parameter. And you'll also see now that we're not classifying all as good, and these will not be included in the analysis. If I don't like that, I can always go in here and drag out and add them, or I can simply say classify all beats as good, and the red box expands to include all beats. So that's kind of how we can actually classify beats, decide if they're good or if they're bad, and kind of look how they compare against these parameters. Next, I'm going to talk about the beat averaging view. And we'll go to that via the toolbar tip, but we can also go through the menu. And you'll see here, since I'm averaging, it says I'm using 4 of 4. The black line is the averaged beat, and we can't see very well here, but there's 4 green traces in the background here that are the 4 beats of that group that are being used to determine that average. The average or black line here is what's being used to find the different parameters for the ECG. And I can keep moving through. You see that this data is also linked to LabChart as well. As I move through, it takes me to each individual group of beats. We're told here P start, P peak, P end, QRS start, QRS max, all the parameters that we're looking for show up here as lines. We can right-click on the screen, tell it I don't want to see certain ones if it's a little too cluttered for you. We can even manually edit these if I don't think it's finding the right spot. And of course I can clear manual edits and move things back. So just a good graphical representation of batches of beats or one specific beat of how LabChart is detecting. It's kind of a good way to make sure that all your parameters are working correctly and you're detecting the regions that where you want them to be detected for the ECG signal. And just kind of a little heads up, if you have blocks of data, averaging will not work across them because we lose that last beat. It's just going to move to the next block and then average from there as if it's starting over again. Next, we'll talk about the table view. So pulling out hard numbers from here for each specific beat. These are all the analysis features that are available, all the things that can be calculated with the ECG Analysis module. Heart rate, PR intervals, P duration, QRS interval, QT interval, etc., etc., JT interval, T peak. We also can include the average, the min, the max, and the number of beats that we're analyzing. And we can see here that there's a few. We've identified 75 beats, but only 63 do our current parameters allow us to identify the PR interval. Another good way to make sure, okay, yes, our parameters are working for our data. We're seeing things that we want to see. We've identified 74 beats. Okay, we're actually identifying QRS for all of those. You can export this as a text file or a comma-separated delimited file out of LabChart if you'd like. You can also add it to the data pad. And here with options, we can decide what we want to see. Do I want to see R interval? No. Do I want to see intervals in seconds, milliseconds? How many significant figures? Do I want to show the summary information? This is these averages, mins, max, and counts down here at the bottom. So just a way for you to customize this view for exactly what you're looking for by doing this analysis. And of course, we have our old friend here, the help menu button. That'll take you to the exact point in the ECG analysis topic that talks about the table view. And of course, we can access the table view from here. And we can also access the table view options from the drop-down menu as well. And I'm going to talk about the analysis plots now. There are 4 different analysis plots that are available to us. QT to RR interval plot. Matter of fact, we'll go ahead and open them all. QT time plot. How does the QT interval change over time of the analysis? And of course, just like everything else, these are linked to the individual beats, our little X's here. And these are really good for this specific QT elongation and amplitude increase, that this is the drug we're applying here to the rabbit. It's a good way to kind of indicate that, to see that. We actually have a comment here saying, hopefully I pronounce this right, doftalide, we've actually given it to the rabbit at this point. And then we see the time it takes for it to actually start affecting the T wave. Of course, all of these plots can be copied and exported as an image outside of LabChart. So if you need to put it into a paper or a presentation, you can definitely export these. RR versus time. And last but not least, we have the waterfall plot. Waterfall plot is great for, especially for this file. Basically what we're looking at here are all the ECG waves just stacked up on top of each other. Here would be the first one at this point, and here would be the last one. This is great because we can see, okay, P waves, slight depression from the drug application. There's a slight increase in the R wave as well, it looks like, with the drug. But we can really see that T wave elongation once we apply the drug, and also the increase in amplitude as a result of the drug. Really great three-dimensional view of this. These are great for presentations. So we can just, I mean, it's clear as day here to anybody looking at it what's happened. And I can left click and hold and move this around all three axes to get the best view for it. So maybe not great for hard analysis, we're not getting hard numbers from this, but a great visual representation of what the drug is doing to the ECG waves over time. So like here's, like I said, here's time 0, here's the final time, and each one of these ECG signals or events being stacked up on top of each other. And if I hit reset, it takes me back to the default view. So that takes me to the end of ECG analysis. I'm sorry, I'm going to have to move a little fast today. Actually, I forgot one thing. Let's not forget about these. These are very important. If I add in channel, there are actually ECG analysis channels as well. And these will, if we select for things to update in real time while we're recording, these will calculate and update in real time and continue as a trace. So how do I access these? I add a new channel. We perform our ECG analysis, or just tell it that, okay, we want to analyze while sampling, take a look and perform an analysis. And if I left click on the channel title, in the channel pop-up menu, I see an ECG analysis option down here. If I left click this, I get the output settings, and I can put out these specific parameters as a data trace. RR interval, heart rate, PR interval, P duration, etc., etc. I'm going to do QRS interval. We hit OK, and we get a data trace that updates through the file and in real time according to what our QRS interval is doing. Probably a great one for this, for the specific file. QT interval, okay. Obvious what the drug is doing. We add it right here at this comment, and that QT interval just increases over time in reaction to the drug. So very handy to have. So that does take us to the end of ECG analysis. My apologies, I misspoke earlier. And now we're going to move on to HRV. HRV, heart rate variability, what is it for? What do we use it for? Just looking at the effects of stress, the effects of certain disease states on the variability of the heart rate. And are they indicators of our disease state? So I've opened my HRV demo file. We can use a simple finger pulse here if we want to, or just a simple pulse wave, or if we like, we can actually use an ECG wave. And there's no right or wrong here. And of course, we can do both online during sampling and offline post-sampling analysis with the HRV module. So now we're going to kind of talk about module setup. I've got my data here, and just like the ECG analysis, we have our menu up here with settings and some various options below. And of course, we get a toolbar tip that comes up. It allows us to get the settings, subject data, the different windows in HRV, and to tell it to analyze. So first thing we want to do, we want to set up the module to analyze a specific channel and tell it whether we want to do a selection like we do with the ECG or do a whole file. So I hit settings. So again, that's under, wrong one, sorry. HRV, settings. There's two tabs, R-wave detector and analysis. First we're going to talk about R-wave detector. And I'm going to point out again, once again, we have our shortcut to the help menu topic for R-wave detection in the HRV module. Just like with ECG, what is our data source? What channel contains what we want to analyze? We have an ECG signal in channel 3. Great. Do I want to do whole channel or selection? Just like ECG, I can decide here one way or the other. I'm going to do whole channel again. We get a preview of how HRV is analyzing. We don't quite have the dots in here like we would in ECG analysis. We should get some out here, out in the data view, but not in our preview here. We can see the lines where the ECG module is saying, okay, this is a good event that I need to look at. Nice way to see if your analysis settings are actually working correctly. Down in the lower left here, we see signal pre-processing. These are just ways for us to pre-process the data to make it easier for LabChart to detect our events that we're going to use, we're going to analyze with HRV. So say we had some noise in here and derivative gave us a better indicator of how to detect things. Not the best here, but it could be an option if you have a really noisy file. We would change the threshold a little bit. We can invert it if we have more of a better negative spike than we do a positive. It can happen with different QRS complexes. 45 hertz low pass filter. We can add this if we have a lot of high frequency noise that we want to get out and actually just try to isolate our signal of interest, either whether it's pressure or whether it's ECG. Position of the event. Do we want it to be at a certain threshold? Do we want to be at the max of a certain threshold like we have it set now? Or do we want it to be the 0 after the threshold? So it goes up, and when it crosses the 0 line again, that will be where our marker will be. No right or wrong here. Depending on what we determine over here with pre-processing, some are better than others. The derivative, of course, will also combat a fluctuating baseline, and it's probably better to use a 0 after threshold with that. The low pass, like I said, will just remove high frequency noise and make your signal cleaner. And of course, here's our threshold to determine events. We've got a good one for our ECG right here, about 1 millivolt. Retrigger delay. What does this mean? This means that after LabChart finds an event, say there's maybe some noise or some spiky data here that it's falsely triggering again according to that threshold, we can tell LabChart to wait for a little while. So if we know what the minimum RR interval is going to be, to look for another QRS complex, or look for another R wave, I should say. Just a way for us to tune the module according to our data and how it identifies the events. Okay, so now we'll talk about some analysis options available to us. We're going to go to the second tab here. Interval classification. What does this mean? We're obviously looking at RR interval, the width of them, and we want to decide, okay, well, what's not good at all? What do we not want to analyze? What's outside of normal variation? And what is normal? Depending on the interval length in milliseconds, if it's too low, we can consider an artifact. If it's lower than 200 milliseconds, in this instance, it's going to be considered an artifact and not used. If it's between 200 and 800, we're going to consider this ectopic, non-typical. We have a choice in HRV whether we want to choose those to be analyzed or not. Then we have our normal range between 800 and 1400 milliseconds here. Our upper ectopic range, 1400 to 2000, and artifact above 2000. The subject moved. We have this big crazy spike that gets identified. That doesn't work for us. We don't want it. And as I said, if we check this, we can exclude ectopics from the analysis if we so desire. They will be color-coded according to the event markers, and we'll talk about that here in a couple minutes. The histogram that's created from the analysis is one of the views, the bin size, so basically your temporal resolution. How fine do you want to go? Do you want the bin sizes to be 10 milliseconds, 5 to 100? Variation threshold, also known as delta NN, or the normalized RR interval. What's a large difference? Here we have, and what is it? It's shown in the NRV, or the normalized RR variability report, as NNXX. What is that? What do we consider to be a large variation? It has to be greater than 50 milliseconds. Spectrum. This relates to the spectrum calculation that the HRV module does, basically taking the signal from the time domain over into the frequency domain. Amplitude in relation to frequency instead of relation to time. Fast Fourier transform is the process that does this, the FFT. The size, what does that mean? The higher the FFT size, the better frequency resolution you're going to have, the more precise you are on specific bands. The lower the FFT size, the better amplitude resolution you have. What's a good or bad? Default is 1024, but whatever works best for you. Is amplitude more important to you, or is frequency resolution more important? And make your decision according to that. Window, something that's multiplied times the fast Fourier transform to make it a little bit more precise. Right or wrong, there is no right or wrong here. Whatever works best for your analysis. None, Welch, Parzine, Hahn, cosine, etc. Just how it weights the windows. Overlap. For each window, it takes half of the previous one in the next window. 2/3, 3/4. These will increase accuracy, but they will also increase analysis time, and it might bog your computer a little bit. The max frequency that we see in the spectrum, pretty obvious here. We just set to 0.5 hertz. We can set a higher, lower, however we want. The frequency bands that are important to us in HRV. Between 0.15 and 0.4, depends on what you define these as, could be the high frequency band if you're familiar with HRV. Between 0.04 and 0.15, the low frequency band. Below 0.04, the very low frequency band, and of course even below that, I think there's a very, very, very low frequency band. I can't remember the term off the top of my head, but that you have to have a large recording, say over 24 hours, to determine that one. It normally occurs during sleep. So now we've gone and set all this up. We can hit OK. LabChart goes through and analyzes the whole file. And we have, just like with other analysis, we can go here, left click and hold, and it's going to tell me, okay, this is a normal beat, it's green, this is beat number, the interval, and how long it is, and at what time it occurs. So we've done our HRV analysis on this channel. Just like I said before, usually we miss the first beat just to give LabChart enough data points to perform the calculations. Subject data for this file, if I know I want to track that sort of thing, I can go ahead and enter it here. Name, age, gender. The different windows that are available to us, we'll cover these later. Marker options. Do I want to show normals? Do I want to show ectopics? Do I want to show artifacts? Just lets me decide here. We don't have any ectopics defined here yet, and I'll show you what that looks like a little bit later here. I can actually add an R wave if I want to. I can do that by marking it with my cursor here, or the active point in LabChart. Excuse me, we have to do it in the proper channel. We add an R wave. Okay. That is actually an ectopic beat according to the parameters we have here. Left click, says it's ectopic, it's yellow. I can delete short artifacts. Say there is an ectopic that's short like this. Like this guy right here. It'll look for them if they're really, really short, really close to another interval, and delete them. We'll talk about that. We can actually print our full HRV report. We can export the RR intervals as a text document that we get, or a CSV document, comma separated variable. NN intervals, spectrum NN intervals. You can export the full report. All options available to us. So if you do analysis here, you might have another software that maybe does a specific thing. You can actually export it, or maybe it's easier to do a graph in Excel. As I said here, we can show R wave markers. We can remove them. We can tell it to analyze while sampling, reselect analyze data, clear analysis, analyze channels selections here. Deleting the short artifacts, going back to it here, doesn't really affect a lot of the calculations, but it can affect spectrum. In the data pad, there are also a variety of things that we can pull out and actually populate the data pad with, so we can get those hard numbers from our data trace. There's an HRV overarching topic, and everything in here can be calculated from specific selections. My apologies today. I think we're going to go a little over. This can be a kind of a meaty webinar here. Today we might go a touch over an hour. So different things that you want pulled out of the HRV analysis, we can actually populate the data pad with them. And if you want to learn more about the data pad, we cover that in another webinar, but that's pretty much the only time I'm going to talk about it today. So the windows and plots that are available to us. Go to HRV here, Windows, or of course I can go out here to the toolbar tip, HRV analysis plot. Oh, excuse me, missed it right here. Sorry, HRV analysis plots. First we'll talk about the point care plot. It relates each RR interval to the following one. So here's our first RR interval on here, and here's the next one right here on an XY axis, and relates them to each other. You can change the normal, so you can see we have our lines here for ectopic, normal, ectopic, and artifact here. This will be a great way for it, and you can actually adjust these parameters on this among other plots. I'm going to go ahead and do a smart tile here. And now you can see we have a red artifact that will not be used in our actual analysis. And I'm left-clicking and dragging these dividers. And of course, our ectopics become yellow. A little bit more about the point care plot. What does this ellipse here mean? What does this little black box here in the middle mean? The black box is the mean of all these beats. The mean XY values for these beats. The ellipse is the standard deviation. If you want to know more than that, you might have to talk to a HRV analyst or analysis specialist. That's about as far as I go here, but definitely read some papers. They'll talk about more why those are important for HRV analysis. You can also right-click in this view and have it show the mean and standard deviation or not. So it removes that ellipse and square. I can tell it to show the limits or not, these right here. I can join all the points. So we start from the very beginning one and join them with lines. Why would you do this? Obviously it's not great for large selections of data, but maybe for something smaller you kind of want to see how things progress from beat to beat. And the line could definitely give that option to us. Another great thing you can do here, you can use color. What does this mean? You'll notice we have different colored beats now. It gives you the indication of the age of the interval. Red, earliest intervals, very beginning of the file. Green, the middle of the file. The blue, the most recent. So it gives us kind of an indication of, as we progress through a recording, where are these intervals happening. So we had a green one here. Actually right here we have a blue one that occurred very, very, very late in the recording that's actually ectopic. And we have a few very early on that are ectopics. Great ways to see, do we tend to becoming ectopic later on in the file or in the beginning or in the middle? Just kind of another analysis feature. And of course you can go here, right click and turn those off and they become all red. Period histogram. With the normalized RR intervals, the NN intervals, and count, where do they all kind of end up? What is the typical interval, and what interval is the most common? So for us here, if you look up on the upper left-hand side, most common interval is between 1,110 to 1,120 milliseconds. There's 83 intervals that fall in that bin. If we right-click here, we can change the view. Of this particular graph. You can also do a step, whatever works best for you. And of course the bin width is where we were talking about back here in the settings under analysis. How big do I want this bin width to be in the histograms? The delta NN histogram. What is displays a histogram of the differences between successive normalized RR intervals, so NN intervals, normalized RR intervals. What is the difference between all of them? And what is the most common difference? Once again, we can change our bin size here as well. It will be affected by that 10 millisecond change. Tachogram, RR interval to interval number. You can see here our RR interval is going up, down, how it's kind of going over time or over the interval numbers. Once again, we can come out here, change the various parameters about what we consider to be ectopic, what we consider to be an artifact, what we consider to be a normal variability. You can also right-click here, show comments as they occurred during the file, and also use color here as well. Early, gonna get a little brown here, moving over to middle of the file, and move to blue towards the end of the file. Go ahead and close that. Spectrum. We can adjust. Here we are looking at the spectrum for our RR intervals, the power that's occurring, how it's varying in the very low frequency, the low frequency, and the high frequency regions. We can also mouse over, just like we can with the parameters for ectopic and normal and artifact and the other views, get our double arrow, left click and hold, and move these values around, whatever works best for us. And just like with ECG analysis, all the views I've gone through here for HRV, I can say edit, copy HRV spectrum, take it out as an image, and paste it into a Word document, into a PowerPoint, etc. for a presentation or a paper. You can also right-click here, change the view just like we did before, filled bars, function, show the spectrum bands or not, show it as a PSD or don't. All the things are available there for you. So you can show a spectral density, which it is right now. So the square root of the intervals divided by 1,000 hertz, or you can just do the square root of the intervals, the actual power, absolute power of it. Whatever particular method you want to use. Last but not least here, we're going to talk about the HRV report. Total number of beats, classification boundaries used, discontinuities, etc., etc. Standard deviation of NN intervals, standard deviation of delta NN, the ratios, the number of normal beats, the number of ectopics, the number of artifacts, etc., etc. And like I said, we can actually print this if we'd like. We can export it if we'd like, in order to get it out, copy it, and paste it somewhere else. And that takes us to the end of HRV. So very quickly, and it's not going to take anything away from the topic, we're going to cover the cardiac access extension. Cardiac access is going to look very different from the past two modules we talked about. You're not going to get any sort of drop-down menu or toolbar tip or anything like that. And what cardiac access is used, it's used for offline analysis. It will not do it in real time, but we can actually calculate some of the other ECG leads as long as we have leads 1 and 2 recorded. So there's a documented relationship according to certain mathematical equations between leads 1, 2, from leads 1 and 2 to leads 3, AVL, AVR, etc. So how do I do this? We have the ECG, or excuse me, we have the cardiac axis extension installed here. We've recorded leads 1 and 2. All right. So if I go here to channel 3 and left click the channel title, we get our channel calculation menu, and you'll notice I have this ECG lead option available to us. Whenever the ECG, or excuse me, the cardiac axis extension is enabled, this is going to show up here in the specific channel calculation menus. Left click it. Not an ECG lead, that's fine. We want to set it up. We hit setup. We're going to do lead calculations. We hit on. We say, okay, lead 1 is in channel 1, lead 2 is in channel 2. I want lead 3 in channel 3, AVR in channel 4, AVL in channel 5, and AVF in channel 6. Once again, we have our link to the help menu here for this, so if you forget or are curious about this, you can definitely click on here, see the calculation being performed, hit OK, and LabChart goes through, calculates all these leads, names the channels, and populates the data. Great. So I only have to record leads 1 through 2 to get all of the AV leads. There's no options here for the V's, V1 through 6, but definitely saved you some electrodes here. So what else can this do? One of the great things about cardiac access, and pretty much its namesake, is underneath window we have a cardiac access view that we can bring up. I left click that, and for a specific selection it will show me lead 1, lead 2, lead 3, AVR, AVL, AVF, and also gives me the cardiac vector. So I'm going to smart tile here really quick to kind of show things a little better. We get average vector, instantaneous vector, and the time. So I want to, if you notice if I don't select anything, this does not populate. I can select a specific ECG, and it shows it here. Lead 1, lead 2, all the other leads for it, and it gives us the cardiac vector here. What does this do for us? We can show the cardiac vector as it changes, and we have a bunch of different speeds we can do here through this beat. So if I hit this, we're in real time, we can't really see it very well, so I'm going to slow it down here, and I'm going to go slow. I'm going to hit add. So the green loop here represents the T wave, and according to what the cardiac vector is doing during that actual wave of the ECG complex. The blue one, which is barely visible right here, is for the P wave, and the red will be for the QRS complex. So you can see as we're moving through this beat, you can see our little placeholder here. Going through, going through, going through. And you see our instantaneous vector is a green arrow that's pointing up right now. We're not doing anything. And then once we start getting into the P wave, you'll see it follow this blue loop right here, if you can see that in the webinar, maybe not. The vector changes, starts pointing down. We have actually have our degrees here as well, 0. Go through it, then we start going out into the QRS complex. Go through, recover, and the ventricle repolarizes at the T wave, as we saw before. So great for teaching, great to show what the cardiac vector is doing in the chest for specific points in the ECG. And that, in a nutshell, is what the cardiac access extension does. You can also copy the cardiac access that we're seeing here and export it as well, just like you can our other views. So that kind of takes us to the end of what we're going to talk about today. I'm sure I see some questions out there, but I'm going to go ahead and minimize this. And before I forget, put up my contact information. So as I said, I'm the technical support engineer for North America. You can reach me at this telephone number. There's my email address. If you have any questions about what we talked about today, think about a question later on after we close the webinar, or just anything. It doesn't even have to be related to what we talked about today. Your hardware, your software, give me a call. I'm the person you need to talk to. If you think there's problems in the software, you have problems with your hardware, I'm also the person to talk to. I deal with our return materials process if you have a broken piece of equipment. So I am the main contact for all these things. So give me a call. No issue is too small. So without further ado, we'll go ahead here and